Hi, you guys. This is Missy McCarthy, Okemos High School math instructor, with your lesson for section 4.1, Congruence and Transformations. In this lesson, you're going to learn how to identify and describe transformations in the coordinate plane. We've done some of this before, but we're going to add a new transformation today. And also we're going to use properties of rigid motion to determine whether or not figures are congruent, or to prove that figures are congruent. So first of all, we're going to look at the definition of transformation. Again, we've looked at transformations in the past, but the definition that we're using for transformation in this section is a change in position, size, or shape of a figure. A transformation is a change in the position, the size, or the shape of a figure. We have 4 different types of transformations here. Last time we only had 3, so we're adding a new one. The first type of transformation that we have is a reflection. You guys also know this as a flip. And a rotation, you guys know this as a turn. And translation, you know this as a slide. And then the last one we have is a dilation. There is no really easy name for dilation, but a dilation, it makes something bigger or smaller. It makes something larger or smaller. So it's a change in size, and that's one of the stipulations for a transformation, to change the size. Now in isometry, another vocabulary word is just a transformation that preserves the length, the angle measures, and the area of the original figure. So it does not change the size at all. So an isometry has the same exact shape, the same exact look, but it may just change the position. A rigid transformation is another name for an isometry. So if the transformation preserves the shape and preserves the size, then it is an isometry, and it is a rigid transformation. So of the transformations we know, a translation is definitely an isometry, because the only thing that it changes is the position. So it is an isometry or a rigid transformation. Here we look at notation. If you take any point x, y, you add one number to the x coordinate, you add another number to the y coordinate, then you will have translated that figure horizontally a units and vertically b units. A reflection is also an isometry. It does not change the shape or the size of the image. So it is a rigid transformation. All the side lengths the same, area the same, all of that. There's 2 different kinds of reflections we're going to look at, and that's how you reflect an object over the x-axis and over the y-axis. To reflect it over the y-axis, you can see here all of your x values just become a negative x. And to reflect it over the x-axis, all your y values just become a negative y. Then our next one is a rotation. A rotation is an isometry. It preserves length and area and shape and size. There's 3 different kinds of rotations here. We can rotate it about the point 0, 0, 90 degrees clockwise, 90 degrees counterclockwise, or 180 degrees. So you can see here what you would do to each of them to rotate them 90 degrees clockwise. The x's and y's switch places and the x's become negative. 90 degrees counterclockwise, the x's and y's switch places and the y becomes negative. And then rotation about the point 0, 0, 180 degrees, x and y stay the same, but they both become negative. And then the last one is a dilation, which is not an isometry because it changes the shape. So when we're done, the 2 figures are not congruent. But to do a translation, you just multiply each the x and the y coordinate by a scale factor. If that scale factor is bigger than 1, then your image will end up being bigger than the original. If your scale factor is between 1 and 0, then your dilation image will end up being smaller than the original. Okay, so let's practice here. It says apply the transformation to the given polygon and then identify what kind of transformation it was. So for this one, let me pick a darker color. That's not really darker, is it? Let's go with purple. All right, so for this one, we're taking all of our x values, they're becoming negative x, and we're taking all of our y values, and they're staying the same. So our new image values, A prime would be negative 1, 1, B prime would be negative 3, 2, and C prime would be negative 3, 5. So I'm going to plot the original first. 1, 1, that's A, 3, 2, B, 3, 5, that's C. So here is our original, A, B, C. I'm going to do the image in a different color. And the image is negative 1, 1, that's A prime, negative 3, 2 is B prime, and negative 3, 5 is C prime. A prime, B prime, C prime. All right, so we can see that this resulted in a reflection over the y-axis, a y-axis reflection. And it is a rigid transformation. Okay, let's try this one. We're going to do the same thing. We've got vertices K, L, and N, and we're going to take everything x, y, and it's going to become 3x, 3y. So our K prime is going to be negative 6, negative 3. L prime is going to be 3, negative 3. And N prime is going to be 3, negative 6. So let's plot our original points. Negative 2, negative 1. 1, negative 1. And 1, negative 2. So there is our original. I should label this K, L, and N. And then our new one is negative 6, negative 3, K prime, 3, negative 3, L prime, and 3, negative 6, N prime. And there's our new. And this is a dilation by a scale factor of 3. And definitely not an isometry. The second figure or the image is definitely not the same as the pre-image. All right, so here's our wrap-up. 1, do you know what the following words mean? Make sure you know what a dilation is, an isometry is, and a rigid transformation. Can you draw and identify transformations in the coordinate plane? And can you use the properties of rigid transformation to determine or prove that a pre-image and an image are congruent?